we present to you our project titled Krishimitra, a smart farming sustainable future project, presented by Lynn Rose and Nandana Sandeep. Indian farmers face immense challenges with over 60% relying on agriculture for their livelihoods. However, poor soil health, inefficient resource use, and improper animal care lead to significant losses, with 30 to 40% of crops lost due to pests and diseases. Additionally, 70% of farmers struggle with water scarcity. Our solution is Krishimitra, an AI-based solution that offers smart tools like disease detection, automated watering, and smart feeding systems aiming to optimize resources and increase farm productivity, ensuring sustainability and a brighter future for Indian agriculture. We used the design thinking process in order to make our project, beginning with the first step, empathize, by understanding the user's needs. We studied using online resources and surveys about farmers and the issues that they faced, such as crop diseases, water scarcity, inefficient animal feeding, and poor security. We also researched the daily practices of farmers, noting their struggles with limited resources and lack of automation. Then we moved on to our second step, which was to define by framing the problem. Our farmers and agriculturists have the problem that they are unable to handle farm efficiency and sustainability, often encountering problems such as degrading soil health, improper animal feeding, and depletion of natural resources when managing large farms with limited resources. An ideal solution would be an AI-based tool that provides innovative solutions to farmers that include a smart feeding mechanism, cooling system, automated lighting system, moisture-based self-watering system, and intruder detection, among many more. Next, we proceeded to ideate by brainstorming solutions, and we developed a set of potential solutions such as an AI-based disease detection system in plants, smart watering systems, automated animal feeding, and smart cooling systems, as well as security monitoring via AI cameras. Then we moved on to prototype by building tangible solutions. We began with a digital prototype that demonstrated the feasibility of integrating AI and IoT systems for precision farming with some initial feedback and real-world validation. Next, we created our early prototypes using smart AI tools with OpenAI and Google Gemini before we made the first physical prototype. Next, we moved on to applying entrepreneurship in various parts of our project, such as designing the project ready to scale, catering to both smallholder farmers and large agriculture businesses across India. This was possible because our project is modular and adaptable to different farm sizes. We also needed to establish a clear market need, which was already present because India's agricultural sector employs around 80% of the workforce but only contributes to 17% of the GDP, and over 75% of farmers own small farms, and 60% of these farmers face significant issues with water scarcity, which is among the problems that our project seeks to solve. Moreover, our low-cost solution ensures market penetration, especially in developing economies. Krishimitra uses affordable IoT and low-maintenance hardware to keep operational costs low and to make technology accessible to farmers. Farmers adopting IoT-based solutions can achieve up to 30% reduction in input costs through smarter irrigation, pest control, and resource management. We also plan to partner with the Indian government's Pradhan Mantri Krishi Sinchai Yojana (PMKSY), which aims to improve irrigation across 7 million hectares by 2025. Next, we ensured that we used eco-friendly and innovative materials. Through the use of renewable energy, as well as innovative materials like wood and recycled electronics, our platform helped reduce carbon footprint and propose more sustainable future for farmers and the environment. India generates over 3.2 million tons of e-waste annually, making it the fifth largest e-waste producer globally. However, we could use recycled circuit boards and components to reduce the environmental impact of e-waste and contribute to resource circularity, ensuring that valuable materials are reused rather than disposed of. Also, Offering our AI-based pest and disease detection system ensures farmers address their issues with the crops without resorting to harmful chemicals over all of their plants. Next, scientific thought and principle. We ensured that we use scientific thoughts and processes throughout our project, using sensors such as the soil moisture sensor to detect soil resistance to moisture levels. The higher the water content, the lower the resistance. And based on electrical conductivity, the sensor detects how well electricity flows through the soil, which varies with moisture content. Also, our automated cooling system measures ambient temperature using temperature sensors that detect thermal radiation, while our disease detection system in leaves uses machine learning and image processing with the help of computer vision and pattern recognition algorithms, as well as visual data, to spot subtle changes in leaf structure that indicate diseases. Next, we ensured that we took into consideration economics, making sure that our project was portable and durable. We made a breakdown of the components involved in our system as well as the predicted cost, ensuring that we considered that a lot of the electrical components would be entirely recycled. And we have mentioned a breakdown of the cost as well as the portability and durability here.
Hello, Nandano, how can I help you today?
What are some good crops to grow in Kerala?
Hello there. Kerala's climate is fantastic for a variety of crops. Given its high rainfall and humidity, you could consider rubber, which contributes substantially to Kerala's economy. Spices like pepper, cardamom, and cloves are also excellent choices, as Kerala is famously known as the spice garden of India. Coconut is another staple, thriving in the coastal regions. For food crops, rice and tapioca are widely cultivated and essential for local consumption. Based on past trends, focusing on a mix of these cash and food crops can provide a good balance and stable income. Good luck with your harvest.
What are the best fertilizers for the region then?
Namaste. Finding the right fertilizer depends on your soil and crops, but generally, balanced NPK fertilizers nitrogen, phosphorus, potassium, are a great starting point. Based on Indian agricultural data, urea 46% N is widely used for nitrogen, while DAP 18% N, 46% P2O5, is popular for both nitrogen and phosphorus. Muriate of potash MOP 60% K2O is commonly used for potassium. However, soil testing is key. It helps determine specific nutrient deficiencies and tailor fertilizer application for optimal yields. Consider checking with your local agricultural extension office for affordable soil testing and personalized recommendations. You've got army worms. For army worms, you can use insecticides containing active ingredients such as acetamiprid or fluticamide. You've got aphids. For aphids, you can use natural methods like water sprays, insecticidal soaps, neem oil, or diatomaceous earth.
गुजरात में गर्मियों में उगाने के लिए सबसे अच्छी फसलें कौन सी हैं?
गुजरात में गर्मियों में उगाई जा सकने वाली सबसे अच्छी फसलों में भिंडी, ककड़ी, तोरी, अदरक, टमाटर, लौकी और ककड़ी शामिल हैं। इन फसलों की उपयोगिता और मानक उत्पादन की दृष्टि से ये फसलें गर्मियों में उगाने के लिए अच्छे विकल्प हो सकते हैं।